I guess before I start, I know a couple of people were like looking for teammates. So if you guys are thinking, or if you're thinking about building on Uniswap and looking for a teammate, if you guys want to like raise your hands, if you're looking for a teammate, and then you guys can like look around and see. Anybody want some teammates? Okay, cool. Cool. Yeah, thanks for coming to my talk. It's just going to be like a brief intro on V4, and then with some live coding, we'll kind of just jump into it. Yeah, so we'll talk about like the differences between V3 and V4. I think it's really helpful for understanding like what's possible in V4. Things that might have been possible in V3 but weren't super viable are now like obviously very viable in V4. We're gonna have talk about like the mental models, like the types of hooks that you can build, kind of help you guys narrow down and like scope what projects you guys could work on. And then at the very end, I'm just gonna do like a live coding, just kind of walk through like what a hook looks like, ways, what these parameters mean, what you can do reasonably inside a hook. So yeah, I go by Sauce. I'm Uniswap Foundation's protocol engineer. One of the many great core contributors to Uniswap V4. I worked on the pool manager. I know the position manager like the back of my hand. I'm the maintainer of V4 template. And then now that V4 is done, people ask me kind of like, what do I do? And so it's a mix of like special projects, DevRel, developer grants, and just anything kind of adjacent to V4 and technical stuff. So you can find me on Twitter, GitHub, and Telegram at suacepoint. Cool. Before we get started, I want to briefly just touch on the fund metrics of V4. We recently crossed $1 billion in TVL. There's been almost 3,000 hooks initialized, and we do roughly like almost $700 million in volume a day, and this is just on V4. V3, V2 continues to still get a lot of traction, but yeah, V4 is kind of ticking up. One cool stat I like to call out is like 65% of the volume on V4 is happening on L2s, predominantly Unichain and Base as expected. So yeah, good times. So for the people that are new to the room, Uniswap V4, like what is it? It's very similar to V3. A lot of the math and the benefits that you get from Uniswap V3 carry over to V4. The main big difference is there's two philosophical design principles behind V4, and one is gas efficiency, making it more efficient to do things, and making it more expressive for developers. And so on the left, you see V3. Every pool was its own contract. Every token or every pool would maintain its own tokens, and then hopping between pools. So if you wanted to trade ETH into DAI, you'd maybe touch, like, I guess in this diagram, 4 different pools, facilitating transfers between each contract. In V4, it's one contract. All the state lives in one singular contract. It holds all of the token balances, and with some really nice advancements, you can kind of really reduce some of the gas complexities of multi-hop swap. And so you can kind of see these are all pools. All the tokens live in this one big contract, and then we have like hooks, which are these like little modules or plugins that you can think of that sort of customize the behavior of a pool. More concretely, like what is V4, like what's different? So what I talked about was the Singleton architecture. So it's one contract that holds everything. This leans into like the gas efficiency principle of designing V4. One actually really, really big feature that a lot of developers rely on is a continuous fee spectrum. So on V3, you are limited to 4 different fees. And in V4, you can go anywhere from 0% micro fractions of a BIP all the way up to 100%. We've seen a couple like meme coin pools launch at like 2% that actually do like quite well. And then because of this continuous fee spectrum, we also said like, let's add dynamic fees. And dynamic fees let developers sort of customize, what fee to charge. It's not opinionated by the protocol. You can increase it, you can decrease it. You can change it every transaction if you want to. You can change it like once a week. So yeah, another big feature in V4 that was not available in V3. ERC 6909, I won't really touch too much on this, but it's like internal claims tokens. Again, just reduces a lot of like the gas complexity of calling out to ERC20s. We have flash accounting. Essentially, this relates back to this design where you can kind of maintain intermediate balances as you're like hopping through multiple pools. And what that does is it allows you to string together a bunch of operations while reducing the token transfer. So you can, swap and use the outputs of your swap to create liquidity, right? And you're actually not swapping, taking out the token and putting it back in, right? You're just kind of doing it all in one atomic operation. Again, this leans into gas efficiency. And then lastly, we have hooks, right? You can attach arbitrary logic and modify the behaviors of a pool, again, into more developer flexibility, developer expression. Quickly on hooks overview, it's kind of what you would expect. So during the swap process, we check, hey, does this pool have a hook? Should we call out to before swap? If so, we call out to an external contract, run arbitrary logic, and then we come back to the core protocol, facilitate the V3 math, similar with after swap. And so hooks are external contracts, right? They live outside the pool, but they're attached to pools, and what you can do with a hook is really just modify the behaviors of it, offering like what we call like programmable liquidity. Every pool has at most one hook contract, but one hook contract can work on multiple pools. So if you build a hook for ETH USDC, of course it works for ETH Tether or ETH DAI. There are 14 functions available. You can mix and match. You don't have to use all 14. You can pick and choose. You can use one. You can use two. And so, yeah, that's V4 in a nutshell. And so just diving down into like the types of hooks that we've seen and how do we like categorize and how do we think about what's possible, we coincidentally have 4 of them. The first one I call liquidity profitability. So it's hooks that provide higher returns for the liquidity providers for participants. And so what we can think about, like how do we actually improve liquidity or profitability? One thing is dynamic fees, obviously, like just charge more money so there's more volume or more just fee revenue directly paying liquidity providers. There's this term that we use called rehypothecation, where can we take liquidity in the pool and make it productive through other services like lending? Can you take liquidity from the pool and deposit it into a lending market? Again, increasing the returns for liquidity providers. Does your protocol have auctions related to it? Can you add an auction layer and use the auction proceeds to distribute value back to liquidity providers? And so yeah, that's liquidity profitability. Liquidity depth is another type of hook. So these are hooks designed to increase participation, support larger swap sizes, and so can you design liquidity incentives that are sustainable in long duration for people to participate in liquidity provisioning, making the pools deeper, being able to support higher swap sizes. Just-in-time liquidity. So this is kind of how Euler works, Euler swap. It borrows money just in time to create the outputs of a swap. And so what we've seen with Euler swap is like trade sizes of like $3-4 million. Limit order hooks are technically increasing the liquidity depth, right? There's more capital for people to trade against. And so attaching limit orders to your hook can, support larger trade sizes. Hooks that manage liquidity in some shape or form. So like, actively managing liquidity, concentrating liquidity, you can think of as liquidity depth. Our third category, asset class. This is probably like the biggest class of hooks that are possible. And it's really trying to customize the pool to support like the tokenomics or the behaviors of the token, right? Not every ERC20 behaves the same. RWAs have compliance requirements. So it's like, how do we add KYC to a pool? Liquid staking tokens accrue value. And so how do you design a pool for a token that's perpetually accruing value? Maybe there's a custom curve that you could do, a different pricing algorithm. Maybe you can manage liquidity in a way that shifts the liquidity as the price is increasing. Rebasing tokens behave very weirdly, and so can you wrap and unwrap these rebasing tokens? Governance tokens. Designing a pool where you can provide liquidity but still maintain voting rights to participate in governance. Meme coins are, yeah, another big asset class. And so how do you optimize volatility? How do you make it where it's exciting to trade, but people don't lose their shirt, right? Another asset class that I don't have on this list is like prediction tokens. Prediction tokens are very interesting in the sense that they trade from $0 to $1. There's an expiration time, and so like as you approach expiry, how does the behaviors of the pool change, right? Our last category of hooks is what I call public goods. It's kind of the catch-all bucket. Trading order types, you can think of benefiting swappers, so limit order, TWAM, which is kind of like DCA, maybe adding volume-based discounts to trading, you can think of as a public good. Priority cancels, this is kind of like a research topic right now, and priority cancels are this idea of, can we ensure that liquidity operations happen before swapping happens? So like, can liquidity providers remove their liquidity before somebody trades against it? Oracles, it's a very straightforward. So how do you design oracles to be manipulation resistant? Outside of price oracles, we could design volume-based oracles, and maybe your lending protocol wants to parameterize something based on volume. And then lastly, volatility oracles. And those are the 4 types of hooks. And so I know some of you guys have been taking pictures. So there's resources to get involved. We have this hook directory, which is like community built hooks. And so you guys can take a look at what's been built out there so far. It's a pretty good resource. There's a lot of stuff that's been built. V4 template, which I'm going to dive into. It's a great starter kit. It sets up your dependencies, has like a template hook, has your tests set up, scripts to deploy. And then if you need to get a hold of us, our Discord is also a great place for technical questions. If you guys have any sort of issues with building or have questions, yeah, Discord's a great place. More resources, of course, we have documentation on it, V4 template, and then you also have me as a resource as well. Cool. So I guess, yeah, now I'm just going to jump into live coding, and we'll see what happens. Cool. Can you guys see that? Okay. Yeah, so this is V4 template. It's just cloned down, and this is what a hook looks like. Like I said, it's a contract. You can kind of designate the behaviors of the hook, so like before swap. And essentially, yeah, it's just valid, like a contract, and any valid solidity works here. You could do really bizarre things if you wanted to, like deposit into compound for whatever reason. More practical applications are, so this example is counting. So every time somebody trades on this pool, what if we did points calculations? So if this mapping was something different, let's just assume message sender is the user, right? And you could increase points and track points for users. Other things that you might want to do is dynamic fees. And so if you have a function and the function looks at the pool key, maybe looks at the swap parameters. So maybe for bigger swaps, you want a discounted fee. We could also include time here, right? I won't implement this function itself, but you can think of just an abstract function where, hey, given a bunch of inputs, return a fee, a value, right? And as you can see with Copilot, it's kind of suggesting that, hey, in before swap, you can run this logic to calculate your fee, and then you return it back to the core protocol. The core protocol will then read this value and apply it to the swapper, right? So that's some things you could do. In after swap, you get the results of the swap. So this balance delta here. So after a swap happens, you could maybe charge an additional tax. That's possible to do in hooks. So charging an additional tax. I'm just gonna kind of pseudocode this, but it looks like pool manager dot take. Something like this, right? So inside after swap, based on the results of the swap, you could then charge an additional tax or monetization. You could also do things like donating back to the pool to reward liquidity providers. Yeah, that's also possible. There's also the liquidity hooks. There's 4 of them. So before you add liquidity, you could run something. Before you remove liquidity, you can also do something. There's also after liquidity, so after add. One thing that we've seen anecdotally is like you can charge penalties. So, before you add liquidity, or maybe it makes sense to do it after, right? If you had like some sort of mapping, like creation time, position ID or something like that. Like this is just all pseudocode, but like, and then so after you create a position, you record its time, and then whenever the position's getting removed, you could do like something like this. Whoops. And then you can compare you can compare the difference between like how long the position's lasted, and if the position has only lasted for like 30 seconds or something like that, you could then like take their fees, by calling pool manager dot take. Right. So yeah, there's a lot you can do here. Again, any valid solidity works. There's a bunch of functions too on the pool manager for swapping, donating, modifying liquidity. Like a position or a hook could create positions in before swap and then after swap close the position if it wanted to. I'll quickly dive into the tests. And so we also have tests set up in V4 template. It deploys the pool manager for you, creates mock tokens, deploys the hook, creates the pool with the starting price, creates full range liquidity, and then you can kind of see in the tests that we're like running a test swap on it, and we're checking that hey the state has changed on the hook. You can also observe the swap amounts. And I think if you guys are interested in building this weekend, I would highly, highly recommend use tests to like validate your idea. Wouldn't really try using like test nets because like the reverts aren't super like helpful. And so yeah, testing will be a really, really nice resource.
And you don't use Foundry to test, you use a pure like Foundry to test.
Yeah, it's a Foundry repo. It's a Foundry template. Are you a hard hat guy? Sorry.
So is it like with testing, if you're locally like forking the mainnet
Mm-hmm.
and with Anvil,
Yeah.
and then just running instead of test, running like scripts that will do like sequence, and then you'll compare the result. Is that kind of like what you mean, or?
Yeah, you could fork. My whole thing with testing is whenever it reverts, you kind of see which function call reverted. Whereas if you go on like Etherscan, it's just like the transaction reverted, and you're like,
Yeah.
where? But yeah, you could definitely use forking. We also have scripts in here too, if that's helpful. So like deploying a hook. You can run these against Anvil. You can run these against Sepolia. You can run them against mainnet if you're feeling crazy. I guess one thing I will mention that I believe. I believe the tests are kind of set up intuitively, or maybe it's the scripts where it will automatically determine your chain ID and then look up the pool manager address for you, so you don't have to like configure a bunch of stuff. Maybe it's in here. Yeah, so in the scripts, you can see that we're like looking up all of the pool manager addresses on all of the chains and stuff. So cool.
And that's all inside the template.
Mm-hmm. Yeah.
Yeah. So you mentioned earlier slide you can do custom curves.
Mm-hmm.
I
Yeah, it's kind of complicated. If you're just starting, it's really involved, but the way it works, the core idea behind it is the hook would take the input. So it looks something like this, and then based on this return, sorry. So depending on how you return this data here, it's kind of confusing with the signage. Sometimes you use a negative, sometimes you use a positive. But there's a way to configure the return such that you signal to the pool manager saying that, hey, I took all of the input. There's no input remaining for the V3 swap math. And so with hooks, you can kind of what we describe as like eject the V3 swap math. And so you take all of the user's input, you calculate your output, right? And then you would provide it back to something like this, right? And then this output that you give to the pool manager will then give it to the user. And so really like the meat and the potatoes comes into like this function here. I just totally like hand waved it, but yeah, you can kind of like roll your own like pricing algorithm. If you want to like read the Binance price, if you want to read Chainlink price, if you have like some really advanced pricing algorithm, it's kind of just like all in this function. And this is roughly how custom curves work. And then yeah, it's in our documentation. I think there's some examples floating around. So cool. Were there any other questions or? Yeah, in the back.
What is your wish?
What is my wish?
So, like, do you want people to build things like Aperture and Crystal, or do you want people to build really weird pools, or to build abilities for other people to build really weird pools?
I would say my wish, and I think the path of least resistance is like building hooks for asset classes. Like how I talked about it earlier, there's like 3 types of hooks. So like designing hooks that are like really good for, I don't know, I guess I'm trying to think of like the most exciting like ERC20s out there. I guess there's, RWAs and stablecoins, there's prediction tokens, maybe like Pendle yield tokens are also like really interesting and thinking about how to get those into Uniswap.
You mean to have like pools with them?
Yeah. Or like how do you design a pool such that it like behaves better for both liquidity providers and swappers, right?
To like safely handle these kind of
Yeah.
like traditional standard pool like will definitely fail with the tokens.
Yeah, or like a standard pool, you're more likely to like lose money or something like that, right? Like if you LP with a liquid staking token, right, that's accruing in value over time, and so because the pool price doesn't account for it, you're more likely to sell it at like a stale price. You're going to sell it at a discount because it's perpetually like increasing in value.
And is that would require like intercepting like you did there with the curve?
Yeah, that's one way of doing it. There's some theories around like maybe modifying the liquidity. So like, we have a function called like modify liquidity. So it'd be like, you would like close a position or something like that and then like reopen it. Something like this. It's like kind of like pseudocode, but you can kind of get the idea. So you'd like close the position, adjust its range, and then reopen it. And the cool thing about flash accounting is you don't actually have to withdraw the tokens here. You would only need to pay the differences.
Do you have any examples with prediction tokens if you want to build a hook?
I don't, but it might be in the Atrium database. Yeah, I do have to wrap up here, so getting cut off. But if you guys want to find me, I'll be floating around. So.